In this video, I'm going to be taking a look at a Philco precision visual alignment generator for television and FM model 7008. Believe it's from the late 40s, possibly early 50s. So, if you've watched my older videos, you've seen me in this video, I'm going to be taking a look at a Philco precision visual alignment generator for television and FM model 7008. I believe it is from the late 40s. If you've watched some of my older videos, you may have seen me perform alignments in the past, and typically I would use something like this WaveTech sweep generator and marker generator in conjunction with a scope set in XY mode for display. Well, what's nice about this unit is it has a built-in display. However, it's a very shallow device. The way they accommodate that is when you want to use the display, pull out this shield and swing out to the CRT. And there is a 3-inch green phosphor cathode ray tube with a crosshatch on the front of it. Now, I picked this up off of eBay, reasonably priced. I was the only bidder. It's not in the greatest condition. However, it did come with 2 of the probes. I believe I am missing what they call the high frequency probe, which had a crystal detector inside of it. What I do have is the output probe and an input probe. And the output probe has this thing on the end, which I think is a terminator, which appears to be made out of bakelite. And this can unscrew from it and just expose some raw terminals. So I'm not sure what that's all about. And the input is just straight coax with 2 alligator clips. Don't know if it works. The seller certainly didn't test it or know anything about it, and I have not tried it. For one, the power cord looks pretty terrifying, and for another, I would much rather want to check it out inside rather than before I try powering it up. So that's what I'm going to do in this video first off, is take a look inside. Now, I looked quickly at the service info, which is available online, and they say that you need to take out the power cord before you can open this up, and you open it up by taking off all these screws around the front. The whole front just pulls out. What I'm not sure about though is how does this come out? Does it just pull out? Or does it screw? I guess it just pulls out. That's not your typical power connector, at least not in my experience. I'm hoping this unscrews and I can replace that cord. It looks like they use that type of UL approved tie-off method to create a strain relief. So, just going to replace the power cord. Missing 2 chicken head knobs. I know I have some lying around. It might not match perfectly, but will do. And I'm missing this, which would have been the original Philco logo that looks like just from a little Philco scope from the same time period. So the full service and owner's manual is readily available online in PDF form, so I downloaded it and printed out a few select pages. First section of the manual is all about the specifications and what it can do and how you would typically use it to align TVs and FM radios, and a few other tricks you can do, like checking the propagation or termination of a piece of coax. What I've printed out is the schematic and troubleshooting. There's also a section on calibration and a section on theory of operation that I skipped. So I give you operational checks, and then if things aren't working right, got some troubleshooting charts. First, let's take a look at the schematic. So they broke it up into sections. Section 1, power supply. for both the sweep generator and the scope. So the high voltage stuff is over here for the scope. Somewhat similar to electrostatic TVs with the centering controls and the way they couple the signal to the plates. And section 2 is an audio generator. I think it's a 400 Hertz test tone. Section 3, vertical amplifier for the scope. So there's the input and there's the scope input leads that I have, and there would be the high frequency probe, which I do not have, but perhaps I can create one. Doesn't look too complicated. I think I've got some 1N34s lying around. I certainly have both those capacitance values and resistor values. Don't know how it was constructed though, what type of coax they would use, and they don't have a spare connector of this type. I don't think. In fact, I don't think I've ever seen these types of connectors before. So on the input we've got a post, and on the output we've got the female equivalent. And the back side of the probes, here's what the scope looks like. So it kind of looks like the output there, and it screws in. And here's the other guy. So if I wanted to make a high frequency probe, I would need to find another connector like this. Or of course I could swap these out for something like BNC, but since I've got at least 2 of these, I'll try to, I would like to preserve this. Alright, so section 4 is the RF generator. They use a 6J6 or 6C4 marker oscillator, and then a 6J6 cathode follower to buffer that marker oscillator, and for a crystal oscillator there's a built-in 5 MHz crystal that you can beat against the marker oscillator, and you can see that beat waveform on the screen, so you can calibrate this. The dial on this marker generator is kind of nifty. So in addition to your usual ranges and marks for frequency here, there's also some marks on the pointer as well. And there's technique they outline in the manual for using this to interpolate or compensate for calibration errors. Because this is really the key as a marker generator. As long as you can sweep some RF, even if it's not perfectly linear and all that, as long as you can have a good marker, you can find where you're at. If you have awesome linear RF generator, and so you get set it up so like each division on their screen is 1 megahertz, you can kind of do away with markers. But when this isn't perfectly linear, it's really nice to have an accurate marker generator. Alright, and then section 5, FM generator. Here's where the magic happens, right here, this gizmo. This is what provides the swapped oscillator. What it is essentially is a voice coil from a speaker with a metal plate on it, close to another metal plate. It vibrates back and forth at 60 Hertz, which produces an FM sweep. And they sweep it from 140 to 250 or 230, a little hard to read that, megacycles. And then they mix it to down convert it for other frequency bands. So here we can see the dial. So you set your center frequency with this, and you set your sweep width with this. I believe we can do up to something like a 15 megahertz sweep width. And then they have a switchable attenuator and then a variable attenuator for the outputs. And here's functions, marker calibration, AM modulated RF, and 400 Hertz audio tone. Off, marker. Oh, I think this is just the marker RF output. And this is calibration mode. AM modulated RF, which I believe is a swept RF, and then just 400 hertz audio tone, and I'm not sure what the function attenuator is versus output or master oscillator attenuator. Perhaps this function attenuator is usable to use when you're in like the 400 hertz mode. And then various bands for the marker and for the master oscillator. Use a lower band for IF and FM radio, and you use the higher band for tuners. They're up into the 100 megahertz plus type frequencies, and then all the stuff up here is for the scopes. Vertical centering, horizontal centering, focus, intensity, phasing, blanking has to do with the sweep, getting the display to look right. Likewise, vertical and horizontal gain will control the width and height of the display. Yeah, width and height. And section 6 is the sweep. I believe that generates the signal that drives that voice coil, and it controls blanking on the scope, so you don't see the retrace. Alright, one reason especially when I get this thing open, is I like to get it working. I don't know if it'll replace my more modern solid state alignment stuff, but it'd be fun to give it a try. But what they don't tell you on this parts list is the wattages for the resistors or the voltages for the capacitors, generally speaking. So these are, I presume, paper caps. Might be 400 volt, might be 600 volt, might be 1000 volt, I don't know. And for some of the electrolytics, they don't give the values either. For example, C103 filter cap on the high voltage supply for the CRT just is 15 microfarad, no voltage. Could try googling that Philco part number, might get a hit, probably won't. So I'm going to have to look at these parts to see what I should order up for replacements. So let's pop this thing open. I've got the power cord out, so now I just need to take out 20 plus screws, it looks like, and then I think this whole front just pulls right out. Before I get to that, though, there was this little door underneath where the power cord comes in. Well, there's absolutely nothing in there. It's probably storage for the probes, I would think, which is a nice touch, but too bad there weren't any treasures to be found inside there. Alright, let's give this a try. It feels like it's hot on one side by something, There we go, just cable rubbing a little bit. Alrighty. Well, first blush looks to all be here. Let's see why it's so heavy. There's a big power transformer in this. Oh. It's a sucker up here. Big rectifier too. 5V4. A couple 6X4s. I've never seen a 5V4 in the schematic. It's 5Z4 here. That's a 5V4. All the tubes appear to be Philcos. I think some of them are replacement though. Like this looks to be, this has like a 1962 date code on it, I think. Sure isn't going to be original. A little bit of crud accumulated in here. pots in the back. Rheostat here. Suspect for calibration. And this is a magical sweep generator. So here is the spider. And it looks just like your standard speaker spider. Hopefully it's in good condition. Looks to be. Looks like it's still springy. Some loose crud floating around. Don't want to get that mixed in there. Ah, but these rubber mounts, they're just gone. Gone. This whole thing is supposed to float on these mounts in a while. See how loose that is. Probably the same type of, same place I get the replacement shock mounts for Philco radios. I can find something suitable for this. So these fasteners, I don't know what they call these things, but they pushed a little wire or a little thing like that, and then they bend these two over on the other side. I have to bend these back and then pull this out. Replace the rubber bits, but don't worry about that until I can actually get it working. And this is the frequency control, I think, from the back side. So I'm guessing that's a variable inductor. Yeah, that must be what this is, which sets the center frequency. It's a very small inductance value with a wiper that you can increase or decrease the inductance. There's a marker calibration crystal. Also, well, there was a rubber band around it. Let's see that. Here it is. There was a rubber band around this at some point that's just fallen off. Probably supposed to hold that in its socket. Philco marked crystal. And now I get the caps. Certainly some of these are paper. And they should be replaced. Looks like there's probably an early diode down in there. Are there any diodes in the schematic? Rather than the one inside this Pro. Not sure. Otherwise, I'm not sure what that little thing is. Anyways, grab a flashlight. Pew down in here. I don't know what that is. So, a lot of carbon comp resistors that might be out of spec. And a lot of caps. Not a lot of caps, but some caps should be replaced. There's some micas that probably are okay. Some tubular ceramics that are probably okay. The coils I certainly don't want to mess with. I think it's the one main filter cap down in there, which is not bulging. Oh. And it looks like over on this side is where the bulk of the filter caps are. So all these guys should get replaced. And big candome resistor. I said, oh, another electrolytic. I don't know what that is. Must be a tube. It's got a shield over it. It's a Loctile tube with a shield over it. The shield has come loose. Not so easy to get at. Not the easiest thing to work on. Hard to get at stuff, so there's a shield on this tube. Now, I suppose if I take this tube out. There we go. And that shift the base a little bit is what pretty much always happens with these stupid lockable tubes. Just get out of the way. Put this back on. There we go. What I'm inclined to do is try to power this up as is. Generally, tester equipment, they use pretty high quality parts, and everything's so hard to get at in this set or device. Kind of like to see how it works. And of course, I'll keep a close eye on things so nothing burns up. In order to do that, I need to rig up some kind of power connector. Unfortunately, I don't see any obvious way to get this apart. But if it doesn't come apart, how the heck did they ever attach these wires? But it sure doesn't want to unscrew. It's one molded piece. I mean, there's no way you could tie a knot down inside there after you get the wires in. It's just not going to happen, so it's got to come apart somehow. Well, twisting it's the only way I can think of. Well, I couldn't figure out that power connector, so I just cheated a little and soldered a line cord directly on the other side of this connector. So, let's see, what's a good way to do this so I can watch it. I guess I'll go on this side. And now I get the CRT flipped open. I want that side down because that's the heavy side, it's the transformer side. Let's see. Alright, got a power switch, it's off. And for function, I'm just going to calibration for now. A, sweep list. Turn the intensity down. Focus. Put these controls sort of in the middle of the range. Alright, I'll plug it into a PR57, which is fused. And that is now on. Dial it down to about 117. And here we go. Now it's drawing a small amount of current. Tubes are lighting up. Rectifiers aren't arcing over. Current draws less than 3/4 of an amp. Turn the CRT into, hey, and I have something on the CRT. And centering control, vertical centering is working, horizontal seems to be working, horizontal gain, yep. Focus, it actually seems to be doing something. Nothing on the display to see, but I don't know if I really should be seeing anything with nothing hooked up. I'll move the camera around in a moment so you guys can see what I see. Now I want to check, see if that sleep generator action actually works. Appear to be moving much or at all. Try increasing the sweep width. Oh yeah. That noise is the speaker thing going like that. be a little dust in there. Alright, I'm going to flip this around so you guys can see it, and I'll hook up a scope to the output and see if we can see on the scope what thing's putting out. Notice the current draw has been dropping too, so hopefully it means the filter cap is forming up. It's been an annoying location, so it's hard to... Yeah, it's cool. Rectifier tubes are pretty cool too. This thing wouldn't be drawing a whole lot of current anyways. Okay, here we go again. I hooked up the input to test point 9 as indicated, so we should see something like that. All is well. And there's the trace. Blinking is supposed to be on. Okay, it is on. Just vertical gain. Dirty control. Seems like it wants to display something. There's a horizontal gain. I don't know what these other controls are supposed to be set to, so I just kind of jumped right to this. Should probably go a couple steps back. Well, let's see. I don't get anything for these two positions. There's Cal, same with the marker. Oh, there it is. Okay, it's not, well, sort of like that. Just to adjust the phasing, which doesn't appear to be doing. Oh yeah, there we go. Oh, yeah. Flips it around. Centering controls. Controls are very dirty, that's for sure. Okay, got the scope hooked up to the output. Well, checking the step attenuator here. When I got to that, sure looks like we got something. I'm checking the variable level, and it looks kind of messy. Thought it'd be a fairly pure signal, and varying this isn't doing anything. Band switch A should be the lowest frequency band. I would expect it to be varying in frequency. Does that change this? Oh, but this is having an effect. The marker might not do what I think it does, which could also very well be the problem. Let's see, there's Cal. Not sure what I'm supposed to be looking at. Cal position. AM RF. 400 hertz, you get nothing on that. Back to AM RF. Let me see that again. Okay, that is varying with this. And if I increase the sweep width, Increasing the sweep width isn't doing much of anything. Not that I expect this thing to be fully functional by any means. And changing this kind of, yeah, it's hard to tell what I'm looking at. Well, that does look a lot like swept RF. But, well, it could be the blinking interval there. There's portions where this signal's changing in amplitude. There's certainly a blinking control on this thing. Let's get back to where we could see. That, I'm going to change the sweep width. So it's minimum. It's maximum. Lower band. It's the higher band, lower band. No, I'm not surprised that it kind of looks like a mess, because typically you do see a lot of harmonics in these type generators. Unlike something like this, we just get a single pure sine wave at the frequency. These things rely a lot on harmonics, so it's not at all unusual for there to be a lot of garbage in the output, and it's expected that it won't matter because it'll be outside the range of your device under test, and it's not a problem. So it looks like we're seeing some AM modulated RF that might also be swept, which would be a little kind of messy on a scope. Changing the center frequency. So I guess I'll really have to go through all the calibration procedures to see if this thing is really working right, but it's certainly putting something out, which is positive. I spent a little time reading the manual. It often helps. And I figured out how to get just the marker output. I had to turn this off and put this function to marker. And now I have an output whose frequency varies with this. But definitely have some dirty controls, including the output level and the band switch. There we go. So let's get some idea how accurate this thing might be right now. It says that's around 4.275 megahertz. Not too bad. 4.1, 0.2, 0.275. Wow. Let's try putting that right on 4. Yeah, look at that. 4.032 megahertz. Jeez. That's pretty impressive. But the B band, let's see, this should be 35. And it's measuring about half of that, actually. 17 instead of 35. Oh, I see that there are marks on both sides of that. Might be have to do something to do with harmonics. So let's go up to here where it shows 20. And now we're at about 20 megahertz. Well, this thing might actually be fairly well within calibration. Speaking of which, if you do cal, you're supposed to see something on this, but I gotta read through the through the manual a bit more. Certain frequencies, yeah, we kind of get something like right there. Try increasing the vertical gain. Okay. Yeah, so it's 5 megahertz crystal, so harmonics of 5 megahertz, we should get kind of a 0 beat to either side of it. I think that's the way it works. But all I can tell you is when I get around 20, That's when yeah, if I go to either side of 20, it goes. You start to get a little waveform, and then it's right about 20, it just collapses. Right there. On the other side of it, it pops back up. So, right. It's kind of touchy. Like, right there. And that is dead on 20. So, that is pretty cool. That is pretty cool. And is this working? It should just be 400 hertz tone. Yeah. Now, if there was something that was going to be affected by leaky caps, I would expect it to be something like an audio frequency generator. So it's going to be low frequency. Higher frequency stuff is going to be the ceramic and the mica caps. The lower frequency stuff is going to be paper caps. So that could be why this isn't working. But alright, it looks like I have got myself a very restorable Philco 7008. So, I guess the next steps will be to dig through this thing and try to match up with the parts list and check the voltage ratings with some of these parts order stuff that I don't have. Some of them are going to be tough to get, like that electrolytic filter can is really buried in there, but seems to sort of be okay. I mean, the trace on the screen does not look all that great, and I've got the intensity up all the way, so could have some low voltages, or the CRT could be weak. Could have weak rectifier tubes, for that matter. All the tubes I'll need to go through and test. And wouldn't mind tracking down some of the missing bits, like get two matching knobs and Philco nameplate. It'd be cool to have. Clean this up a little bit, de-rust these screws a little. See if I can get this green gunk cleaned off. And one of these days, try using it. Oh, and if any of you have any idea how the heck I can go about putting a new line cord in this, I would appreciate it. Oops, the battery on my camera died mid-sentence. What I was trying to say is that is going to be it for this video on a Philco 7008. I hope you enjoyed it.